Have you ever stopped to think about how exactly your voice can leap across miles and pop out of a car radio? It's not actually magic, but the trick behind it is seriously clever. Today, we're going to pull back the curtain on one of the oldest and most important technologies in broadcasting, AM radio. So let's start with the most obvious question, right? Why can't we just take the signal from a microphone, make it super loud, and blast it out from an antenna? I mean, why doesn't that work? Why can't we just, electronically shout really, really loud? Well, the answer really boils down to just one word: energy. The electrical signals that your voice creates are pretty weak. They're low frequency, low energy waves. And if you try to broadcast them just like that, they basically run out of gas almost immediately. They just don't have the muscle to travel any real distance. To get around this, the pioneers of radio came up with an idea that was, frankly, brilliant. They figured, if our little audio signal can't make the long journey all by itself, why not let it hitch a ride on something that can? Here's a great way to think about it. Imagine your voice is a package you need to send clear across the country. You can't just toss it out your window and hope for the best, right? Nope. You've got to put it inside a big, powerful delivery truck that's already built for the long haul. So, in the world of radio, that delivery truck has a name. It's called the carrier wave. This thing is a pure, simple, high-frequency wave, and it is incredibly powerful. Now, by itself, it's not carrying any information. It's just pure, raw energy, basically an empty truck that's ready to do all the heavy lifting for us. And the package we want to send? Well, that's our audio signal. This is that electrical wave from the microphone that has all the good stuff, the highs and lows of your voice, the notes in a piece of music. This is the information we actually want to get delivered. Okay, so how do we get the package into the truck? This is where the real magic happens. What we do is we change the powerful carrier wave so that its shape perfectly mimics our weak audio signal. Specifically, we vary its amplitude, that's just its height, so that the outline of the big wave becomes a perfect copy of our little audio wave. And that process right there brings us to the big aha moment. It has a name you've heard your whole life: amplitude modulation, AM. That's literally all it is. We are modulating the amplitude of the carrier. It's just the fancy technical term for loading our package onto a delivery truck. All right, so we've mushed our two waves together, but what is this new combined radio wave actually made of? It turns out it's a little more complex than just one single frequency now. What's so cool is that this whole process of modulation actually creates brand new frequencies. You still have that original super powerful carrier sitting right there in the middle, but now you also get two perfect mirror images of your audio information, one on each side. We call them the upper sideband and the lower sideband, and this is where your message actually lives. This brings up a really important practical question. We're changing the height of that carrier wave, but by how much? Is it possible to change it too much? Or maybe not enough? Oh, absolutely. And getting that balance just right is everything if you want a clear broadcast. Engineers have a special number for this, and it's called the modulation index. You can just think of it as a percentage. A value of 1, which is like 100%, is the sweet spot. It means the carrier's amplitude is swinging all the way from double its normal height down to 0. That gives you the most power and the best clarity. And this shows you exactly what I mean. On the left, with good modulation, the wave creates this beautiful, clean envelope that perfectly traces our audio signal. But look at the right. If you push it too far, that's called overmodulation. The carrier actually gets clipped off. You lose information, and all the listener hears is nasty distortion and static. So now we know what the signal looks like, but let's talk about the power it takes to send it. We're using this beefy carrier wave to send a tiny little signal. So where is all the energy from the transmitter actually going? This is such a great question, because remember, the actual package, our voice, the music, it's all contained in those two sidebands. The carrier is just the truck, so you'd think that most of the power goes into sending the important part, the message, right? Well, the reality is actually pretty wild. In a perfect AM signal, a jaw-dropping 2/3 of the total power is spent just broadcasting the carrier. The two sidebands that carry all our information, they only get about 1/3 of the total power, combined. Let that sink in. It means that AM radio is powerful, for sure, but it is not very efficient. Most of the electricity is just being used to send the empty delivery truck. It's a total brute force solution that works surprisingly well, but man, it costs a lot in energy. We've gone through the theory of the wave, what's inside it, and where the power goes. So now let's take a quick peek at the hardware. How do we actually build this thing and get it out into the world? Okay, we know we need a carrier wave. We know we need our audio signal. And we know we have to combine them. But what pieces of gear actually do all that work? Well, it all happens inside a box called the AM transmitter. You can really break it down into 4 simple steps. First, a part called an oscillator creates that pure high-frequency carrier wave. Next, the modulator is the part that does the magic trick, combining the carrier with our audio signal. After that, a huge power amplifier gives that new signal a massive kick of energy. And finally, it's sent to the antenna to be beamed out across the airwaves. You know, this quote just sums it all up perfectly. AM might seem inefficient by today's standards, but its real beauty, its elegance, is how simple and direct it is. This was the original technology that gave a voice to the airwaves and really kicked off the entire age of broadcasting. And that kind of leaves us with one final thought. You know, we live in this crazy, complex world of digital signals, streaming services, Wi-Fi everywhere. But the core idea of AM, taking your information and making it hitch a ride on a stronger carrier wave, that principle is still at the heart of almost all wireless communication we use today. So what can this old, elegant, simple solution still teach us about solving huge problems with the tools we have right in front of us?